James the Astro 30 here yet again, and welcome back to AEL. Now if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Today I'm going to have another look at this abomination of an amplifier. Well, it's not an abomination. However, I have managed to fix the DC offset problem, well, to a point. With the power applied at plus minus 18 volts thereabouts, and measuring the output, we can see we've got around about 68, 69 millivolts there now, which is much more acceptable. However, a lot of people would say that, yeah, any amount of DC offset is not good on an output of an amplifier. However, it is at that low voltage supply. The supply is supposed to be plus minus 35. So I would ultimately expect that figure to come down a bit. Well, it's actually currently in the minus, so I expect it to actually come up closer to zero the higher the voltage is. So looking at the schematic, I actually ended up removing Q7 here, this emitter follower which comes off of the collector of the input stage and goes through this 2K2 resistor to the negative rail to the VAS transistor's base. Because I was messing around with this yesterday and I ended up blowing another 4 transistors up, and I also took out 2 BD139 driver transistors in the process as well. Not sure what was going on there, but I ended up one that didn't conduct at all but appeared short circuit to the output stage transistor, and the other one, the diode voltage has dropped down to about 100 millivolts, which is weird. But anyway, and I've now put a fixed resistor in of 560 ohms in place of this current mirror, and that's how we're getting the 69 odd millivolts on the output. 69. And someone did make a comment on the previous video on this that this is actually a Douglas Self design, and well, it wouldn't surprise me. It most likely is. It's probably a random schematic I found on the internet. All I did was add the VI limiter circuitry, I believe, here. So what I want to explore today is why this current mirror circuitry here isn't functioning. Because when I connected the current mirror to the circuit before, well, I ended up shorting this transistor out base to collector. I don't know how it was doing that. It's just strange. It shouldn't be doing that. So that's the first thing I'll be looking at after we now have a look at the output of this thing on an oscilloscope. And that's what the output looks like, and it's nice, clean, and not clipping weirdly, and it's actually clipping symmetrically. We'll also notice there's no ringing on the positive going peak anymore. Well, I figured out what the problem with that was. I'll just turn that back down so I'm not driving the output transistors hard for no reason. All I did was install a 100 nanofarad supply line filtering capacitors on both the positive and negative rail. Yeah, and that got rid of that ringing, which is oscillation, which is coming off of the supply lines. Yes, I just farted. That's McDonald's bacon and egg muffins for you. Now, what I want to do is I want to, without shorting shit, is re-implement this current mirror into the input stage here and just see what our DC offset voltage is and if I blow the thing up. So let me get to reconfiguring the circuit. Well, first impressions aren't that great. We've got 200 odd millivolt DC offset back again. Okay, is this thing working as an amplifier? That's the next question. Well, that would be a yes. So, okay, the current mirror does appear to function. The amplifier is not loaded into the dummy load, it's just going straight into the scope. So, that's really weird. I would have expected the DC offset to be a lot better with the current mirror than it was with the fixed resistor. So, alright, what I might do is I might substitute out the NPN transistors for BC546s instead, because I've already changed these two constant current sources to BC556s respectively, and just see if I get any different result here. Unfortunately, that was worse. I even changed the input stage transistors to BC556s. They were 557s. And, well, I've gone back to the fixed resistor idea. And currently we're at 81 millivolts, so yeah, it's actually made it worse. So I might change back to the 557s, and then I will change the voltage to plus minus 30 volts and see if that offset drops down. Not really, to be honest. We are at plus minus 31 volt roughly, and for some reason the quiescent current has changed to only 8 mA, which, okay, I guess is alright, but that really should be at 25 to 35. I'm not sure why it's dropped. Could be the change in the VAS setup too. So I'll just see if I can increase the current. Yeah, I can. So I'll stick it at what this supply says, 25 mA. About 26 mA, that's good enough. So what to do about that DC offset? Well, considering 560 ohms is where we are currently, it may need to be lower. So I might put a 500 ohm trimmer and a 120 ohm resistor in series with it, going to the negative rail, and see if we can trim that out. Hopefully we can. Wish me luck. Well, that did seem to actually prove fruitful. We're now at a much more respectable minus 8 millivolts. It probably could come down further. The purpose of the 120 ohm series resistor with that potentiometer there between that and negative is so we're not bringing the base of the VAS transistor down to negative. That'll cause a short circuit in the biasing section, and it will not like it. Ask me how I know. So I'm not sure what resistance value it is now, but I had to turn that pot significantly up or down in whatever respect you want to look at it to bring the DC offset down. So it won't be 560 ohm. I will measure it, and but first what I want to do is I want to see if this is still functioning as an amplifier, in other words, outputting a signal. Yeah, well it is, but unfortunately I had to go back to the 560 ohm fixed resistor instead, because when I turned the power on with it loaded, it drew over an amp of current. So yeah, it didn't like having the VAS transistor that close to the negative. But out of interest, I am going to measure what that total resistance is. So it's out of circuit, so it's not going to affect anything here. So I'll just measure the resistance. 360 ohms. That shouldn't have been an issue, but it's only, what, 200 ohms difference? But yeah, it didn't like it initially. So let me just go do some further testing here. Never mind, it was the bottom power supply going into current limiting. The amplifier is still loaded, and we're at 37 mA roughly. I will just remove the ground. Dropped by a milliamp, so yeah, that's perfectly fine. So I know that the DC offset component value needs to be around about 330 ohm. So we'll see if we've still got an output. Oh yeah, excellent. Okay, so we should have an amplifier. I'm not going to drive that too hard. I don't trust those output transistors. So we've got 12 there goes current limiting. About 12.3 volts RMS. Whereas before current limiting took over is about 18 watts RMS into 8 ohms, which is okay, not too shabby. So what do I put this little amplifier's output power at? Well, I'm going to say probably the 50 watt mark. It wouldn't be any higher than that. It may get to 60 watts RMS. Yes, I farted again. I'm just going to drop that bias back down again, because you've got to let the amplifier warm up and readjust the bias accordingly. So I'm just waiting on some parts from order I've done, because I'm going to change these output drivers to the TIP 41 and 42C respectively. I want to mess around with this bias circuit here and go back to the original one as per the schematic, using a 1K trimmer and a 2K2 resistor in the voltage divider network there. So I guess the next thing to do would be to check that this thing actually will run into a 4 ohm load. So I will reconfigure the load into the limit. Make sure that my current limiting is down. There it goes. So just make sure that it can handle that initial spike. That's the only problem with current limiting. One of these other power supplies would probably work a lot better than what this is. Yes, yes it does. Okay, so we know it will run into 4 ohms just fine. So I just want to see, once I reconnect the supply, that it doesn't go into current limit. Well, it did there for a second. So yeah, that's really not an issue. The next thing to do would be to put it into a speaker load. Now that I know it's okay for 4 ohms, so it should be fine for 6. All that can really happen here is it blows the speaker. Here we go. Okay, yeah, that's the current limiting of the power supply. It's a bit annoying. It is working, but it's very noisy. Very, very noisy, in fact. I'm not sure why either. Anyway, let's turn the oscillator back on. Turn it down because it sounds like I'm swearing. I'm going to change the frequency to 200 Hertz. Yeah, it seems okay, albeit that background noise. I don't think it has anything to do with current limiting. No. So, yeah, trying to test this amplifier on this sort of setup with that linear supply at the bottom there makes it awfully difficult. But I'm not really 100% sure why the speaker is noisy. That was when I disconnect the input. Oh, well, there goes the noise. Whoops. That's better. That's coming off the oscillator. Interesting. Stop doing that. Yeah, that's coming off the oscillator. Yeah, there you go. Alright, well, I've eliminated what the noise was. It's nice and quiet now. That's only because there's no real attenuation at the input side of this circuit before the oscillator. So, not sure what the input sensitivity of this is either, which is kind of an issue, but I don't really want to take it up to full power yet. I want to actually put this on a PCB. But what I want to do is I want to do another video on this later, but I want to implement a few changes, mucking around with the bias network here, changing the transistors and including the VI limiter. Now the one thing I'm not going to do is I'm not going to test the VI limiter on the breadboard. The only way to test that is to short the output, which is never a good idea. But but I want to actually have this on the PCB version, so it's got inline fuses as well. So if I do short the output, the VI limiter doesn't work properly, or it fails to do what it's supposed to do, then at least it will blow one of either of the fuses, which is the whole intended purpose. So at least there's some form of protection there. Testing it on the breadboard, even though the power supplies have current limiting, yeah, I still don't want to do it because of all the exposed componentry and wires going everywhere and things not rated for the current that they're going to be passing. Like these little wires here would not be able to handle 5-6 amps of current running through them. But that'll be something to explore. But the DC offset issue is fixed. I'm happy with that. It's outputting a signal, which is also good. So what I want to do to finish this video off is run some music through this and just give it a sound test, see what it sounds like. So that's what I'm going to set up next before I turn it off. And just a side note as to why that current mirror is not working correctly. Well, it's working in the respect that the signal comes out clean, so it's operating as it should in the input stage. But the reason why the DC offset is considerably high, actually higher than the fixed resistor, well, that's twofold. Choice of transistors and other external components such as resistors. Because I've changed the circuit topology and the types of transistors used, and I also got rid of that emitter follower, well, all the values that have been chosen for the constant current source and the current mirror were designed with those other components in circuit as a factor. So what would have to happen is you'd have to play around with different values of resistors in the constant current source and in the current mirror until, you know, you get that DC offset balanced down. Excellent. Sorry. Excellent. So that's working as it should. And it doesn't sound too bad either, so I'm quite happy with that result. So yeah, as I say, the next step is to mess around with the components a bit more, add the VI limiting, possibly route a PCB for it so it can be tested properly. Yeah, I'm still on two minds actually whether or not to double up the output stage, that is have parallel output devices, so 2 PMPs and 2 NPNs respectively, each with their own degeneration resistor, just to help with moving the current especially into a 4 ohm load. Don't know, leave your thoughts below. That just means the PCB will be a little bit larger because I'm trying to keep it, well, to the $5 US 100mm by 100mm maximum, so I don't have to pay the next tier up, which would mean that if it was over 100mm wide compared to its height, yeah, that's a good probably 16 bucks American, which is a lot different to the $5 American. So there's things to consider. The drivers themselves, I've got connectivity issues too. Drivers themselves don't appear to be getting hot, so don't require heat sinking. Neither does the VAS. So the VAS is hardly getting warm at all. Neither are the drivers. So yeah, I'm going to turn that off now. And there was bugger all turn off transient, which is nice. So next thing to do, as I said, is to do all that. And yeah, I'll make another video on that. But I've got other things that I'm going to be doing on the channel in the meantime. I'm not just going to constantly make videos on the one subject, because that's going to bore people. Seeing the same, like in the past I've uploaded part 1, 2, 3, 4, etc. of a project, one after the other, without breaking it up in between. And yeah, going by the view count, it progressively goes lower and lower each part. So it gives me the impression that the interest rate of it is not as great the more parts I upload. So I'd have to break it up in between by uploading another video on something else, just to give you, the viewer, something different to look at rather than a breadboard sitting on the desk. So anyway, I'm going to leave this video here. If you enjoyed it, please remember to go down below, comment, like and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, have a great day. Here's a tip, don't go to McDonald's for breakfast.